Hello students, here we are with the part 2 of lesson 5 inside the atom standard 8 Maharashtra board, and myself Mrs. Prachi Surdikar will explain you this lesson. Students, if you have not watched the previous video and the part 1 of this lesson, please do watch the part 1 of this lesson for better understanding of this lesson. And also like, subscribe and press the bell icon. So, we are going to cover the atomic structure in this video. In our previous video, we have seen what is atom and what are different atomic models. So, an atom is formed from the nucleus and the extranuclear part. So, these contains mainly three types of the subatomic particles. So, these three subatomic particles that are present in an atom are nucleus. The first subatomic particle is nucleus. So, this nucleus is positively charged, and the entire mass of an atom is concentrated in this nucleus. So, this nucleus contains two types of the subatomic particles called nucleons. So, nucleus is positively charged. It is present at the center. The mass is located over there, and this nucleus contains two subatomic particles. Their names are protons and neutrons. So, what are the two subatomic particles of nucleus? Protons and neutrons. The first one is proton. Proton is a positively charged subatomic particle. This positive charge on the nucleus is due to the protons in it. This proton is represented by the symbol small p, and hence a proton carries a positive charge which is considered as a plus 1e. So, the proton is having the positive charge. The number of protons in the nucleus of an atom is the atomic number of that element, and it is denoted by the Z. So, if in an atom there are 7 protons, then that is called as the atomic number of that element. It is denoted by the Z is equal to 7. Suppose if one atom is there in which one proton is present in the nucleus. So what will be its atomic number? Z. The Z will be 1. The next is neutron. Neutron is an electrically neutral subatomic particle. It is denoted by the symbol small n. So this atomic nuclei of all elements except hydrogen contains neutrons. Only hydrogen do not contain neutrons. The mass of a neutron is approximately 1 U, which is almost equal to that of a proton. So neutron is electrically neutral and it is also present in the nucleus. Now the second is the extranuclear parts. So extranuclear part in the atomic structure includes electrons revolving around the nucleus and the empty space in between the nucleus and electrons. In my previous video, I told you that the atom structure is similar to the solar system structure. Like sun is at the center and all the planets are revolving around the sun. Similarly, this nucleus having protons and neutrons are at center, and all the negatively charged electrons are moving around the center in a circular orbit. So that part is called as the extranuclear part of that atom, and in this extranuclear part of an atom electrons are present. So electrons are having negative charge on them. So electron is a negatively charged subatomic particle and is denoted by the symbol small e, and minus sign is also present. So E minus is the symbol of electron. So this electron carries 1 unit of negative charge, that means minus 1 E. Now, the number of electrons in the extranuclear part is equal to the number of protons in the nucleus, Z. So, whatever the number of protons having positive charge are present in the nucleus, that much number of electrons which are in negative charge that are also present in the extranuclear space. So number of protons is equal to the number of electrons. So number of positive charges will be equal to the number of negative charges, and that is why those both charges get balanced with each other, and hence an atom is electrically neutral. This scientific reason is asked, so you have to write the answer that the number of electrons in the extranuclear part is equal to the number of protons in the nucleus, that is Z, and therefore electrical charges are balanced and the atom is electrically neutral. Now, some questions are asked over here that how many types of the subatomic particles are found in atom? You know what are subatomic particles? Protons, neutrons and electrons. Which subatomic particle are electrically charged? Protons and electrons are electrically charged. Which subatomic particle are present in the nucleus? Protons and the neutrons are present in nucleus. And where are electrons revolving around the nucleus placed? So the electrons are revolving in extranuclear space of an atom. Now, representation of an element. A total number of proton and neutron in an atom is the atomic mass number of that element, and the mass number is denoted by the symbol A. So, number of protons plus number of is the atomic mass number of that element. So they are denoted by the symbol Za. For example, carbon. The atomic number of carbon is 6, means there are 6 protons in the carbon and the 6 electrons, or the 6 electrons in the carbon. And what is atomic number? Atomic mass. Atomic mass is the sum of protons and the electrons, that is 6 plus 6, that is 12. So C612, you can see how it is written over there. So that is the representation of an element with its atomic mass number A, and atomic number, that is Z. So here the proton number of carbon is 6 and the mass number of carbon is 12. Atomic number is the number of protons present in the nucleus, and mass number is the number of protons plus number of electrons. Now the next is distribution of the electrons. So as per the Bohr's atomic models, electron revolve in a stable shell. These shells have a definite energy. In a previous video, you have seen various shells: K shell, L shell, M shell and N shell. These are the various circular orbits around the nucleus, and those circular orbits around the nucleus are called as the shells. So these all shells have their own definite energy. The shell which is nearest to the nucleus is called as the first shell. The next shell is called as the second shell. And how they are referred? That K shell, L shell, M shell and N shell. And their numbers are N is equal to 1, 2, 3, 4. Now, how the electrons get distributed in these different shells? For this, for distribution of this electron, there is one formula called as 2n square. You can see, complete the table. In that table you can see the shell, the shell K shell. If we considered, then n of K shell, the number of K shell is the first shell, because K shell is the first shell after the nucleus, hence n is equal to 1. Now you have to put this value in the formula 2n square. 2 into n value is 1. 1 square is 1 and 2 into 1 is equal to 2, and that is why how many electrons will be present in the K shell? The maximum 2 electrons are present in the K shell. Now you have to solve the further. The second shell is L shell. It is the second shell from the nucleus. So n is equal to 2. Now you have to put this value in the formula 2n square. So 2 into n value is 2. So 2 square. 2 square is 4 and 4 2 is 8. So maximum 8 electrons can accommodate in the L shell. Similarly, in case of the M shell, it is the third shell. So n is equal to 3. The formula is 2n square. So you will write 2 into 3 square. 3 square is 9 and into 2, 9 2s are, it is 18. So maximum 18 electrons can accommodate in the M shell. Similarly, you have to write for the N shell also. So now, once that is done, the electronic configuration of the elements has been done. Now, what is electronic configuration? So, electronic configuration is the shell-wise distribution of the electrons in an atom of an element is called electronic configuration of that element. So now you know how many electrons or how many electron number is present in an atom. If you want to divide those electrons in the various shell, you have to consider the maximum number of that shell that can be occupied, the maximum number of electrons that can be occupied by that shell, and that is called as the electronic configuration of elements. Here one table is shown. You can do with this table, you can understand the concept of electronic configuration. So the first atom is hydrogen. The symbol for hydrogen is H. How many electrons are present in hydrogen? One electron is present. So here they have shown you various shells: K shell, L shell, M shell and N shell. And in bracket they have written the maximum capacity. For example, in front of the K, 2 is written. So what is 2? The maximum number of electrons that can present in that shell. So after, there cannot be accommodation of the 3 electrons in the K shell. You have to write only and only 2 electrons in the K shell. Then in L shell, maximum 8 electrons can accommodate. In the M shell, maximum 18 electrons can accommodate. And in the N shell, maximum 32 electrons can be accommodate. So hydrogen is having 1 electron. So you will write that 1 electron in the first shell, which is K shell. So L, M, N shell will be vacant. So your electronic configuration will be 1 only. The second one is helium. The number of electrons in the helium are 2. So you will write those 2 electrons in the first shell, K shell. Then L, M, N shell will be vacant. So electronic configuration will be 2. Now the next one is lithium. Here electron number is 3. So out of these 3 electrons, first 2 electrons will go in the K shell. Now how many electrons are remaining? Only 1, because in lithium 3 electrons are there. Out of that, 2 electrons will be in the K shell and the remaining 1 electron will be in the L shell, and that is why the electronic configuration is 2, 1. So this is the electronic configuration of lithium. Carbon, the electrons are 6. So out of 6 electrons, 2 electrons will accommodate in the K shell and remaining 4 will be in the L shell. So how will you write electronic configuration? 2, 4. Now next is nitrogen. The electrons are 7. Out of 7, 2 electrons will be in the K shell and the remaining 5 electrons will be in the L shell, M and N shell will be vacant. So how will you write electronic configuration? 2, comma 5. Then if we jump directly towards the sodium, the sodium's electron numbers are 11. So now out of this 11, 2 electrons will be in the K shell. Then maximum 8 electrons. How many remaining? 9 electrons are remaining. Out of that, 8 electrons will go in L shell. So inside that L shell you will write 8, and in M shell only 1 electron will be there. So what will be the electronic configuration? 2, comma 8, comma 1. So in this way you have to write the electronic configuration. Students, you also try to understand this and try to complete the table given in your textbook on page number 33 and write the distribution of the electrons in the K, L, M and N shell. So now we have seen that the hydrogen electronic configuration is 1. So here you can see hydrogen where in the center nucleus is given, and in the first circular orbit or in the first shell, K shell, 1 dot is represented. That is nothing but the 1 electron. Helium. Helium's electronic configuration is 2. So how you will write this electronic configuration? So you can again here see at the center nucleus is there of helium, and in the first K shell or the first circular orbit you can see the 2 black color dots, that are 2 electrons which are moving there. In case of the carbon, if you see over here, the electronic configuration of carbon is 2 and 4. So here you can see the nucleus at the center. In the first shell, K shell, 2 electrons, 2 black dots are present, and in the remaining 4 black dots, 4 electrons are present in the M shell. Same in case of the neon. In case of sodium, the electronic configuration is 2, 8, 1. Means in the first orbit, K orbit, 2 electrons will be there. So can you see around that black colored nucleus, there is first circular ring or circular orbit in which 2 black dots, 2 electrons are there. Then 2, 8. In the next orbit, there will be 8 electrons. If you count that, you will find in the second circular path there are 8 electrons, and in the last circular path there is 1 electron, because the electronic configuration is 2, 8, 1. So in this way the electrons are represented by this model, or this is the skeleton of the electronic configuration. Now the next is valency and electronic configuration. So valency means the number of chemical bonds formed by an atom. Suppose if you take the example of carbon. Carbon, carbon can form how many bonds? That is the valency. If the carbon can form 4 bonds, then it is the valency of carbon is 4. If, for example, carbon can form the 2 bonds, then the valency is 2. So valence is the number of chemical bonds formed by an atom. So the electrons in the outermost shell are called as the valence electrons. Whatever electronic configuration we have learned, so in the outermost shell, how many electrons are there? That are called as the valence electrons. For example, sodium, the electronic configuration is 2, 8, 1. So in the outermost shell, how many electrons are there? 1 electron. So what are the valence electrons of sodium? 1. In case of the carbon, 2, 4 is the electronic configuration. So in the outermost shell, 4 electrons are there. So what are valence electrons? 4 valence electrons. The electrons that are present in the outermost shell of an atom are called as the valence electrons. The valency is 0 when electron octet is complete. Now what is octet? Octet means 8. So if 8 electrons are present in the outermost shell of an atom, then it is called as the octet. And duplet, duplet means 2. If the 2 electrons are present in the first orbit of an atom, and that is only the electronic configuration of that atom, then it is called as the duplet is completed. And if in any atom the 8 electron lies in the last orbit, in the in the L orbit, 8 electrons are present, then the octet is complete. And for such elements, the valency is 0. Now, we will see the relationship between valency and electronic configuration. Here, the symbol of the element HCl. The molecular formula is HCl. Valency of the element is 1. Electronic configuration of this element is 1. Hydrogen, we have written the electronic configuration of hydrogen, it is 1. So outermost shell is having 1 electron, so number of valence electrons are 1. So valency of that element is also 1. Then the next is chlorine, HCl. What is the valency of HCl? 1, because hydrogen and chlorine, only one hydrogen is there, one chlorine is there, so only one valency. Now what is the electronic configuration of that chlorine? 287. In the outermost shell, 7 electrons are there, so number of valence electrons are 7. And now 8 minus 7 valence electrons we have to minus from the 8. So 8 minus 7 is equal to 1. Hence 1 is the valency of HCl. Neon. Neon is not a compound, so it will not form any bond, and hence 0 bonds are formed, and that is why valency is 0. The electronic configuration of that element is 2, 8. How many valence electrons are present? The electrons in the outermost shell are the valence electrons, and those are 8. So 8 minus 8 will be 0, and hence the valency is 0. Fluorine. The formula is HF. H and F are forming only single bond, so valence is 1. Configuration is 2, 7. Valence electrons are 7, and hence 8 minus 7 is equal to 1. So in this way, suppose if we take the example of magnesium, the molecular formula is MgCl2. So this magnesium is combined with the 2 chlorine atoms. 2 bonds are formed with the chlorine atom. Hence the valency will be 2. The electronic configuration of magnesium is 2, 8, 2. The outermost electrons are 2. So the valence electrons are 2. And 8 minus 2 is the 6. So that is the valency of an atom. So this is the relationship between valency and electronic configuration. The next subtopics are isotopes, uses of isotopes, and nuclear reactor. These we will cover in our next video. Thank you, students. Thanks for watching.